So this is the bonus project 3 for fluids. I'm going to use my mesh and geometry from project 3, like was said in the handout for Ozbay's class. So here in this test box, I'm going to start with the inviscid flow and come into setup and start working there. So just double checking that double precision and that we have 4 solver processes going. Alright, so we're going to come here first and change this to inviscid. And then we're going to come into our materials. I left the density of air to what it was given for the inviscid flow. And then just double checking that we have a velocity in there. So I'm going to leave it at 0.1. We're going to come down and check the reference values and just make sure it's computing velocity inlet, velocity is correct, density is correct, and we're calculating the surface body. Okay, and come down to methods. For inviscid, we're going to keep it simple. Make sure the pressure for inviscid is under presto. We'll use the second order for the other Reynolds flows, and momentum we can leave as second order. Okay, we're going to go ahead and initialize. And then I believe my iterations is 500. Yeah, we're going to go ahead and run with that. Alright, now with that done, we're going to come to our plots, and we are going to calculate our CP with our wall. So this is exactly what we expected for an inviscid flow. And then to save that data, we're just going to come here, right to File, and I have it saved under Fluids. Okay, so if we come to So I open it up in a notepad and then copy and paste it into Excel. Cool. And that's what I have for inviscid flow. Go ahead and graph everything at the end together. Just finished the inviscid flow. So I'm going to go ahead and come in here and duplicate the same one that we had used for project 3 again. So this is going to be for the Reynolds number, the first case for the Reynolds number where it's equal to 1 times 10 to the 5th, I believe. We're gonna go into setup, double precision for solver processes. Go ahead and start that. Alright, so the first thing, we're going to come here and change this to a laminar flow. Then we're going to come down and just double check that our density, and this is the viscosity that I used for project 3, and I'm leaving the density. And then we're going to come down here, and I did some calculations, and the inlet velocity that worked for me for that viscosity, density, diameter, and Reynolds number I got was 653 meters per second. And then I'm going to come down to the reference values. Just make sure that I'm computing from velocity inlet, viscosity, velocity, and density are correct. We're looking at the service body. Then we're going to come down to methods. We're going to change this to coupled. Change the pressure to second order. Momentum is fine. I'm going to come down here. I'm going to initialize and calculate. Then I'm going to come and plot the pressure coefficient of the wall. This is what we expect. And I'm going to go ahead and save this. Under fluids, this is going to be our go ahead and save that. And then I'm just going to go ahead and do the other ones. The only thing I had to do, I already calculated all of the velocities I needed. So we're going to come in and change the inlet velocity for all of them. So for the second one, where the Reynolds number was equal to 2.6 times 10 to the 5th, my velocity I'm going to use is 1698 meters per second. I'm going to apply that. Just double check my reference values are updated. They have not been updated, so I'm going to go ahead and click here. And they're updated. And initialize and calculate. We're going to go ahead. So that's done. I'm going to go ahead and just delete this one. We're going to plot this new one. And here is our Reynolds number case 2. So now that we imported all of our data into Excel, we're going to go ahead and make this into a graph. So I'm not going to show all the work that I put into it, but here is the chart that I ended up getting for coefficient versus position.